Good morning, students. Today we are going to discuss about decision trees. It's come under Unit 3 of machine learning. So basically, a decision tree algorithm definitely is a machine learning algorithm that uses a decision tree to make predictions. In order to do a better prediction, we can go for this decision tree scenario. So we'll see the elaborately in the upcoming slides. So let's now focus on data classification and prediction. So first of all, we should know the difference between classification and prediction. So what do you mean by classification? So classification means nothing but it's a process of finding a good model that describes the data classes or concepts, and the purpose of classification is to predict the class of objects whose class label is unknown. So simply we can say that just categorize. Okay, categorizing the incoming new data based on the current or past assumption. So already existing data set there now. Based on that, whatever incoming data, we are just classifying and keeping it in any one of the category. So that is what called as classification. But prediction means something different. Here, what exactly happened means something that may going to happen in the future. That is prediction. So we identify or predict the missing or unavailable data for a new observation. So for a new scenario, we are trying to find a new data. So we are trying to predict a new data. So that is what happened in the prediction. So this is the difference between classification and prediction. Now here we are focusing mainly on classification. So many methods of classifications are there. So decision tree induction, Bayesian classification, backpropagation method, association rule mining. These are the some of the example of classification. So let's focus on decision tree here. So when we talk about this individual data records, definitely it has the samples, the tuple values. So various attributes, they have certain values, right? So based on that, the tuples are arranged and these data are taken as a consideration. Then again, these records can be described based on its attributes only. Then in these attributes, in turn, it's arranged in a set of classes. So when we talk about supervised learning, definitely each record is assigned with a certain class label, right? So these things you try to consider when you talk about the set of training data. So this data only we are focusing. Then again, when we are representing as a model, definitely we can represent in terms of mathematical formulas, or we can take any classification rules. Based on that rule based classification, we can do some representation, or simply we can do tree like representation, that is decision tree representation. So these are the major representation models. Then when we are classifying the data, definitely we have to think about the accuracy. So the degree of accuracy is play a vital role in the classification. For successful classification, the accuracy should be better one, right? Then it predicts unknown outcomes from a new data set. That is that, as I said earlier, the prediction is it's all about predicting the future, right? So automatically we are unknown outcome we are predicting from the new data set. So by considering the existing one also. Then usually the classification outcome may be a discrete or nominal values, and sometimes in regression it may contain continuous value or some ordered set of values. Okay, so these things also keep in mind. Then when we talk about decision rule, always we'll try to rely on if then statements. That is, if some condition we are writing, so automatically if the condition satisfied, what will happen next? So that if then statement is play a major role when we are talking about the decision tree, and this can be represented graphically also. So instead of writing as a step-by-step procedure, we can represent in terms of tree-like structure, so that we can easily understand and we easily navigate and we can able to get the decision. So how exactly it will work means it's work like a flowchart. So from look like an upside down tree. So from root node to leaf node, right? So nodes appear as rectangle or circle here, and it represents the test or decision. So either the decision value or it may be a test condition, that is represented as node, and line or branches it usually represent outcome of a test. Then usually the leaf nodes are represented in terms of circle. Okay, so it's a terminal node. So terminal node in the sense there is no further nodes, so it is a leaf node. Then always the top or starting node is a root node, and usually the internal nodes are represented as rectangle because we are further splitting the tree, right? So that's why we are representing in terms of rectangles. So see this diagram so that you can understand. So here, this is a representation for a decision tree for the concept of computer bias. Okay, so usually they are checking the age, and see here, they are checking the age. If it is less than 30, they are considering this as a student, and there is a yes or no condition. Then again 30 to 40, again there is a possibility of yes or no. Then based on the above 40 means automatically based on the credit rating, we can there is a fair value chance of buying a computer. Like that we can classify. So any real world scenario we can take, and by imposing some condition we can create a decision tree. So that is the core concept behind this. Okay. Then let us take another one example, bank loan application. So what is the outcome of bank loan application? Definitely either the loan will be approved or it may be denied, right? So two possible outcomes. So that we will take it as the first condition, approved or denied. Now what we have to do is we have to find the criteria for the loan approved. Then what are the criteria for denying of loan? Denying of loan. Okay, so by considering this fact, known fact, we can able to uh, create the rules. So by creating the rules, indirectly we can able to create the decision or decision trees. Okay, so if they have a CIBIL score, I mean good credit history, then automatically borrower have a great chance of getting the loan sanction. Then loan amount less than some percentage of collateral value, that is 80% of home value. So you know the conditions, right? When we take a home loan or vehicle loan, so they have certain norms based on your income. They will give some value. Usually, if you are buying a home or a car, they won't give the exactly 100% loan, only maximum 80% something only they will give, isn't it? Because remaining amount they have to pay in advance. So that conditions we can consider, and based on that we can able to take a wise decision. By imposing these conditions, we can draw the decision tree also. Okay, so decision rule we are creating. This decision rule actually it is done with the help of partitioning the sample of data. Then based on the class assignment final outcome, we can create the tree, that is terminal node. Then tree partitions again. It's all about mutual exclusive group. Exclusive group. What do you mean by mutual exclusion? That is one rule. If suppose one rule is there, and if the particular tuple is falling into that particular rule, mean it should not satisfy another one. That is the mutual exclusion rule. Okay, so mutual exclusive groups we have to create. Then one group for each terminal node. So these are the things we have to consider when we are creating decision tree. And another one important thing is all paths should be mutually exclusive. Okay, that means for any one case, only one path will be allowed. Okay, so for one condition, the outcome may be something like one route. Okay, there is no parallel or different routes. Okay, so that is the thing you need to consider. When we have a false decision, that we can keep it in a left branch, or we can have a true decision from the right branch. That is also assumption only. Even you can have it in a reverse way also. Okay. Then another one important thing is about disjunctive normal form. So here, non-terminal node, this model identify an attribute to be tested. So this test splits attribute into mutually exclusive disjoint set. See, when we are not able to derive a perfect decision, again we are further growing the tree, because we need to split the attributes. Again we have to impose some new rules so that we can able to create a new leaf node. Indirectly we are doing this disjunctive normal form, and we are, that is, we are narrow downing or we are more customizing the rule. So that is what happened here. So disjunction over a set of rule is allowed here, so that is going to provide better accuracy. So this is depicted in this diagram. You just go through the diagram so that you can understand. Drawing a parallel line in different level, we can able to create various shapes, or we can define regions. So that is defined here. So when we do the prediction, we have two goals. Okay, so one is when we create a tree, definitely the tree should be a smaller one. and it should classify and predict the content very accurately. So accuracy and small size, these are the major things we need to focus. Okay, we will pass that. Another one important thing is small size. A smaller tree, more easily understandable one, and less susceptible to overfitting. So large tree which contain less information regarding classification and predicting cases. So always keep it small so that we can able to predict it in a better way. Uh, Next one is a rule indection. So rule indection, process of building the decision tree or ascertaining the decision rules are tree indection, rule indection, and normal indection algorithms. Okay, so here we can go for the greedy approach. Usually greedy approach means it's top-down approach. So from the root we'll go to the till leaf node. So we have a basic algorithms like ID3, and we can follow the C4.5 algorithm for better decision tree algorithms. So now we need to focus on whether it is a continuous attributes or a discrete attribute. So based on that, we can make some decision. So continuous variable attributes, what will happen is computational complexity will be increased when we have a decision tree approach, and there is a lot of inaccuracy, possibility of inaccuracy, prediction inaccuracy, and it lead to overfitting of data also. But so what we need to do is, usually what we will do, we will convert this continuous variable into discrete one, isn't it? So normally that continuous values, we will make it a small, medium, large, something like that, isn't it? Or with some condition, we will make it into a discrete one, and after that we will apply those rules. So greater than or equal to, less than, so that optimal solution we can able to get. Again, when we are using the discrete interval, we have to consider the number of interval as well as size of the interval. So that play a major role in the decision making. Okay, so these are the things also you need to focus, and how exactly we are making the split. That is also another important consideration, because random selection leads to noisy variable, inefficient production of inaccurate trees also possible. So if you are subdividing the attribute without any prior um, consideration, automatically it will lead to the inaccurate trees. So when we do a splitting of a subdividing attribute or making a split, we have to consider very carefully. So we need to focus which attribute and why we are dividing, subdividing. Those things are very, very important concepts. So when we talk about the efficient model, definitely we have to examine each and every variable, and in order to improve the accuracy of the entire tree, we have to choose wisely which variable we need to focus, which attribute we need to give priority, that are all important. So the split, when we are doing this, automatically we need to calculate the Gini index value as well as the entropy value. Based on that, we can do that. Then suppose we are keep on doing splitting, what will happen? The tree will keep on growing, right? So we need to have a certain time where we need to focus on the ending of tree. So when suppose further we are keep on growing the tree, some in some cases, some point what will happen, there is no significance of it. So there is no information gain. It will create headache only. So in that case, definitely we have to stop the splitting, or we have to stop the growing of the tree. So for this we can use a chi-squared test, which is a statistical test which is used for finding the ending of tree growth. And definitely we have to think the tree should be a moderate one. It should not be too small and it should not be too large for the further complication. So only we have to compare one split with the next descending split. In that way, we can limit the growth of the tree. Okay, so that is another one point we need to consider. And another one method you already know, pruning. With the help of pruning, we can able to improve the tree structure. So how exactly we are going to evaluate the decision tree? That is another one important thing. So definitely when we are evaluating decision tree, we need to focus on accuracy, scalability, robustness, and intuitive appeal. So a lot of methods and lot of ideas are there in order to evaluate those things. So based on those criteria, we can easily evaluate the accuracy, scalability, robustness, etc. So that we will discuss in a separate chapter. Then what some definitely it has some drawbacks also. So the major drawbacks here is there is no backtrack. So that is one of the major drawback in decision tree. We can get local optimal solution only. So as of now, we can get the best solution, but it's not a global optimal solution. Then look at future may also uh, give a better trees. Okay, so basically there is no backtracking and rectangular shaped geometric regions. So in two-dimensional space, regions bounded by lines parallel to the x and y axis is there. So some linear relationship not parallel to the axis. So that representation causes a problem or difficulty. That is another limitation. So what we can conclude here is we can utilize this decision tree method by analyzing the classified data and with a good predictive value and easily understood classification rules we are forming means we can have a better decision tree.